Hey everyone, welcome back. Today we're diving into some wild what-if science. You know, those crazy questions that sound absurd, but have actual math behind them.
Oh yeah, I love those. Like, what would happen if it rained bananas for a day? Spoiler, it is not a smoothie.
Banana rain. Seriously? That sounds like a kid's dream? But I'm guessing it is not all fun and games.
Nope, not at all. First, think about the mass. If it rained bananas as hard as a heavy storm, each square meter would get like 480 kilos in 24 hours.
480 kilos? That is like 1,000 pounds. For a city like New York, that is millions of tons just dropping.
Exactly. And bananas are soft, but when they pile up meters high, the bottom ones start fermenting, producing methane and heat.
Methane? So we're talking explosions, or like a giant compost heap.
Worse, the whole surface gets covered in a sugary mess. Anaerobic bacteria go crazy, sucking out all the oxygen and releasing hydrogen sulfide.
That sounds toxic. What happens to animals and plants?
Animals eat too much and get bloated, die. Plants can't photosynthesize because they're covered in syrup. It is a global catastrophe.
Wow. So it is like a sweet but lethal apocalypse. Okay, let's pivot to a more energy-focused one. Could we power Tokyo with jellyfish electricity?
Oh, that is a fun one. I've heard that idea before. Like, jellyfish have bioelectricity, so catch a ton and wire them up.
Yeah, but are they powerful enough? Like, how much juice does a single jellyfish produce?
A typical moon jellyfish pumps out about 0.5 volts, but the current is super tiny, like microamps. So total power is just a few microwatts.
A milliwatt? That is nothing. Tokyo probably needs millions of kilowatts.
Right. Tokyo's average power usage is around 10 million kilowatts. So you need about 10 trillion jellyfish.
10 trillion. How many jellyfish are there actually in the ocean?
Total biomass is optimistic at 10 million tons. If each jellyfish is 50 grams, that is only 200 billion individuals. So you do need 50 times more.
And even if you had them, they'd die and rot. The logistics would be a nightmare. So that is a no.
Yeah, but the math is fun. Actually, there is another classic. Shooting nuclear waste into the sun. Sounds like a great way to get rid of it, right?
Oh, I've heard that one. Just lob it into the sun, it burns up. But I remember something about it not being that easy. Why?
Because you can just drop it inward. The Earth is orbiting the sun at 30 kilometers per s. To hit the sun, you have to stop that sideways motion completely.
So you need to decelerate it to 0. That takes a huge amount of fuel.
Exactly. The delta V to cancel Earth's orbital speed is about 30 kilometers per s. With current rockets, that costs around $50,000 per kilo.
For 1,000 tons of nuclear waste, that is billions. But wait, wouldn't it burn up before it reaches the sun?
Oh, yeah. It would vaporize into radioactive gas drifting in space, and some of that haze could eventually intersect Earth's orbit. So it is the worst of both worlds.
So we should just bury it underground, like we do. That is way cheaper and safer.
Exactly. So those are 3 examples of what-if science that sound cool but are actually nightmares. Do you want to hear some more weirdly fun ones?
Yes, please. I love this brain-twisting stuff. What is another one that is just mind-bending?
Let's think about everyone on Earth jumping at the same time. What happens to the planet? Does it move?
I've actually done that in a school playground with all the kids. Nothing happened. But what is the physics?
So 8 billion people, total mass like 500 million tons. If everyone jumps, center of mass rises about 30 centimeters. The Earth gets pushed the opposite way.
How much does the Earth move? A millimeter?
Way less. It is like 1,000th of an atom's diameter. So absolutely nothing. But the sound and vibration might cause a tiny tremor.
That is a great letdown, but in a good way. It is like, the more we think we can affect the planet, the more we realize we're tiny.
Exactly. And on the flip side, think about all the ants on Earth. They could lift something huge because they're strong for their size.
Oh, ants. They can carry like 50 times their body weight, right? So if you gathered all ants, what could they lift?
Total ant biomass is similar to humans, about 400 million tons. If each lifts 50 times its weight, that is 20 billion tons.
20 billion tons. That is like, the Great Pyramid is only 6 million tons. So they could lift the pyramid with room to spare.
Yeah, they could lift a whole mountain, but they'd need to cooperate. And they don't exactly have a union.
One more. I heard about what would happen if Earth stopped spinning for a second. That sounds apocalyptic.
Oh, that is a blast. At the equator, the ground moves at about 465 mph. If it stops suddenly, everything on the surface keeps moving east at that speed.
So people, buildings, the ocean, even the air would rush eastward at supersonic speeds.
Exactly. Winds would be like 400 mph, which is like 900 miles per hour. And tsunamis hundreds of meters high would slam into the coasts.
That would erase civilization in a second. So let's hope our planet keeps spinning.
Yeah, and it is fun to think about. But the point is that these wild scenarios often have huge consequences that we don't expect.
So where does this kind of thinking come from? Like, who comes up with these ideas?
There is a guy named Randall Munroe. He did a whole book called What If? He answers these exact types of questions with real math and science.
Oh, I love that book. It is hilarious and so smart. So this is a whole genre of learning, right?
Totally. It is a way to make science fun and accessible. You ask a crazy question, do the math, and learn a ton about physics and biology.
And it teaches us to think about scale and assumptions. Like, never assume anything is simple.
Exactly. The next time someone says, let's just shoot it into the sun, you can tell them it is a terrible idea and why.
Ha! It is like a superpower. Okay, this has been a blast. Thanks for joining me to explore the wonderfully weird side of science.
Anytime, stay curious and keep asking those absurd questions. Just don't try any of this at home.
For sure. And if you enjoyed this, check out our other episodes and drop us your own what if questions. We might do a sequel.
Sounds good. See you next time, folks. Keep it geeky and rigorous. And remember, math is cool, but reality has the final say.
That is a wrap. Thanks for listening, and we'll catch you on the next one. Bye.